Okay, so today we are going to be working with binomial expansion theorem and Pascal's triangle. You started it in last night's homework. So what I'd like you to do is go to classwork day 6. There are 2 questions in the do now. Pause the video, give them a try, and then when you're ready, hit play, and you can watch me go through it. Or if you're good, you can fast forward and check your work and skip to the next part. So I have x plus y to the 4th. So normally we would need to expand this 4 times, and I would need to do the box method over and over and over again. But I don't want to do that. I want to shortcut it. And the way that you learned how to do that was the binomial theorem, including Pascal's triangle, in the homework video. So Pascal's triangle starts off like this every single time. And then you add. 1 plus 1 gives me 2. 1's always on the outside. 1 plus 2 gives me 3. 2 plus 1 gives me 3. 1's on the outside. 1 plus 3 gives me 4. 3 plus 3, 6. 3 plus 1, 4. 1's on the outside. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. 1's on the outside. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. 1's on the outside. So the first row here is always the 0, then the first, second, and so on. This is to the 4th power, so I need to go to the 3rd, the 4th line. Those numbers are used as my coefficients. So I have a 1, leave myself a little bit of space, 4, a little bit more space, 6, 4, and then 1. Then we take the first term, which is x. Each piece is going to get an x. And then it starts at the 4th and it counts down. 4, 3, 2, 1, 0. Then I take my second piece, which is a y. Each piece gets a y. This time I start at 0 and I count up. 1, 2, 3, 4. So I have 1, x to the 4th, y to the 0 is 1. Anything to the 0 power is always 1. So I have x to the 4th. Plus 4, x to the 3rd, y. Plus 6, x squared, y squared. Plus 4, xy to the 3rd. Plus 1 times 1, y to the 4th. And a quick check is to take your exponents of each term and add them together. They should always give you 4. So 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and 4. So we do the same thing with the next one, which is x plus 2 to the 4th. Same line, because it's the 4th. Here are my coefficients. 1, blank space 4, 6, 4, and 1. Same process. I'm going to start with the x. Each term gets an x. I start with an exponent of 4 and I count down 3, 2, 1, 0. And we go the second term, which is a 2. Each piece gets a 2. This time I start at 0 and I count up. So I have 1, x to the 4th, 2 to the 0 is 1. Plus 4, x to the 3rd, 2 to the 1st is 2. Plus 6, x squared, 2 squared is 4. Plus 4, x 2 cubed is 8. Plus 1 times 1, 2 to the 4th is 16. So 1 times x to the 4th times 1 is x to the 4th. Plus 4 times 2 gives me 8x cubed. plus 6 times 4 gives me 24x squared, plus 4 times 8 gives me 32x, plus 16. So what's the difference between numbers 1 and 2? Hopefully you notice that number 2 has an extra step involved because my terms are not both variables. One of them is an integer, and therefore I have to evaluate those exponents. So last night you watched a video and then you were asked to try some on your own. So you can pause this video now and check your work for numbers 1 and 2. If you have any questions, notice how I've color-coded everything just like I did in the Do Now here with the different colors and the different terms. I think it makes it easier. So see if you can find your mistake, or remember, you can always come to extra help. When you're ready and you're done checking, you can hit play and I'll pick back up. So our target is at the end of 42 minutes, I can use the binomial expansion theorem and Pascal's triangle to write polynomials in expanded form. So we're starting off with just a little bit of a review here. I'm looking for the degree. And remember that this polynomial is in factored form. So when your polynomial is in factored form, you are going to add the highest exponent from each piece. So 1 plus 4 plus 1, my degree would be 6. Remember that a leading coefficient is the number in front of the variable with the highest exponent. So when we are in factored form, in order to do that, you are going to take the leading term from each piece, including your exponent. So I have 2, 1 to the 4th, and 3. So that gives me 6. Similarly, the constant term, remember, is the number at the end with no variable. So we are going to take the constant term from each piece with their sign. So I have -5. I have 3 to the 4th. And I have -2. And I'm going to evaluate. Exponents have to come first. So 3 to the 4th is 81. Then I have -5. And I have -2. And then remember that multiplication is commutative, so you can do 5 times 2 if you want to get 10 times 81, and you should get 810. So if I were to write this polynomial out in standard form, it would look like this. 6x to the 6th plus a lot of terms in the middle, plus 810. So this is standard form. So we can tell a lot about a polynomial from its first term or its leading term, and its constant term or its last term. But when you want to expand a polynomial, you want to do it as quickly as possible. And that's why you watched the video last night, and I'm going to review the steps with you now. So example 2, expand a minus 3 to the 5th. So we need Pascal's triangle again. 1, 1, 1, that's how it always starts. 2, 1's on the outsides. 1 plus 2 is 3. 2 plus 1 is 3. 1's on the outside. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1's on the outside. 5, 10, 10, 5. 1's on the outside. 6, 15, 20, 15, 6. 1's on the outside. So I'm going to the 5th power. This is the 0 row always. First, second, third, fourth, 5th. So this is what I'm doing, and I'm starting those as my coefficients. So remember, I'm going to start them, leave a little bit of blank space to set up my other pieces. And then I'm going to take my first term. So I have an A. Every term gets an A. Set those all up. And those start with my highest exponent of 5 and counts down. 5, 4, 3, 2, 1, 0. Then I take my next term. Now this time I have to be super careful because there's a negative. I'm not taking a positive 3, I'm taking a negative 3. So you have to include the negative, and notice how I put it all in parentheses. This term starts at 0 and counts up. You know you've done it correctly if your exponents all add to the original. So 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. And 0 plus 5 is 5. Now I need to do some simplifying and evaluating. So I have 1a to the 5th times 1 plus 5a to the 4th times negative 3 plus 10a cubed. Remember that a negative to the or to any even power is always going to be a positive. So it's important that you pay attention to your signs here. So 3 squared gives me 9 plus 10a squared. A negative to an odd power is a negative, and 3 cubed is 27. Plus 5 times a negative to an even power is a positive. 3 to the 4th is 81. Plus 1 times negative 243. So last step to just simplify from here, I get a to the 5th minus 5 times 3 is 15, a to the 4th plus 10 times 9 is 90, a cubed minus 10 times 27 is 270, a squared plus, I have 5 times 81 if you need to on the side. 5 times 1 is 5, 5 times 8 is 40. So I have plus 405a minus 243. Notice how your signs are alternating. Positive, negative, positive, negative, positive, negative. That's not a coincidence. Whenever there's a subtraction sign, that will always be true. Last one, example 3. In the expansion of x plus 2y to the 5th, there is a term that looks like blank xy to the 4th. Determine what number goes in the blank space. So I don't need to do the entire setup. Well, I need to do the entire setup, but I don't need to do the entire expansion. So I'm going to just set up Pascal's triangle relatively quickly here. Okay. So 5th, 0, 1, 2, 3, 4, 5. Although I don't need to finish it all out, I am going to set it all up just so I know I don't lose anything along the way. So remember, Pascal's triangle gives you your coefficients. Then I have an x. An x goes to every single term. Notice once again, nice and organized, color coding. This is my first one, so it starts at the highest, which is 5, and counts down. 5, 4, 3, 2, 1, 0. Then I have 2y. Each piece gets a 2y. This time, since it's the second term, it's going to start at 0 and count up. But this time I don't need to finish it all out. I just want this piece. So that's this piece here. So I have 5x 2 to the 4th, remember, is 2 to the 4th, y to the 4th. You have to give this exponent to each piece. So 2 to the 4th is 16, y to the 4th. And then if you need to, on the side, show your multiplication again. 5 times 6 is 30. 5 times 1 is 5, plus 3 gives me 8. So I have 80 xy to the 4th. They wanted just a number, so it's 80. So here are some notes just to formalize what we were just doing and the procedure that we followed. The expansion of a binomial is given by, and here's our long formula. These coefficients are given by Pascal's triangle, which remember always starts as 1, 1, 1. And this is always the 0, the first, and then it goes from there. Then I have my A term, which starts with degree n, and it decreases. Then I have my B term, which starts at 0, and it increases. This is the exact procedure that we followed. All you're going to do is just practice from here. So you are going to work on the practice problems, pause the video, give them all a try. When you're done, or at the end of the period, hit play on the video to check your work, because the answers are on the next slide. So here are your answers for your practice problems. If you have any questions, please make sure that you come to Extra Help, and I will be happy to go over any of these with you.